very short, quick note. I have been asked quite a lot sometimes, how do I program or how do I access when I'm writing code on like small computers that are on the local network. So things like single board computers, like Raspberry Pis, could be NanoPi, could be RockPi chip, could be anything, or could even be a Linux machine like a Nook. Anything, a computer that is not your primary development machine. Let's say I am a Mac user and my primary development machine is MacBook Pro. So I'm going around working on the client side, and on the local area network, let's just say we're working on an installation or on a car or could be anything like that. And I need to log in every time to this machine, and then I have to develop it on my Mac, push it to some version control system, for example Git. You're developing on your machine, you push it to the version control system, you log in over SSH to this remote, quasi-remote machine, which is actually on your local network, in close proximity to you, and then you pull the code base and you run it and you see like, oh, there is some mistake, I have to fix a line. And so you have to go back to your Mac, to your development machine, make those changes, push it, pull it again on the remote. It's a lot of back and forth, back and forth, back and forth. So I recently started actually then developing directly on the remote machine, or let's just say the machine of where the final code would be running. And it is primarily important because there are scenarios where, you know, it's not just a simple web app, that it's just a server that doesn't probably require any hardware peripheral access like cameras or microphones, or doesn't need any configuration, for example. In those scenarios, you're fine. You just develop in your machine. Probably you can even test it in a virtual machine on your development machine and then push the code, and then you can just see it running on your remote target machine. What if you have a lot of dependencies? Things like microphone configurations are different in Linux. They're in Mac, and you cannot really test, let's just say, those things on the Mac itself if your development machine is Mac. In that regard, it's much more preferred to do the development directly on the target machine, but from the comforts of your MacBook, let's just say, right, or of your primary development machine. There could be many other scenarios where you're writing a code piece that needs access to many different things. It's running on a single board computer like Raspberry Pi, as I was mentioning. Not always, could be a simple Linux box as well, but let's just say it's a Raspberry Pi and you're making something custom, and then you have all these things that you need to access to the I2C bus and the SPI bus, or it has a specific display and things like that. And so all those stuff cannot be mimicked on your development machine. And then for every single line of code edit, you don't want to push, pull, merge, resolve conflict, and then like try it. There's a lot of waste of time. So I guess the premise is clear that we want to achieve development on a target machine on the local area network. Could it be primarily a Linux machine? We are going to see some examples today, and we're going to do that from all the time. From the first use case is, let's say I have a Linux machine, a normal computer, with a bit of a RAM. So it's not a single board computer, which is lacking RAM these days. I mean, it's better, but it's still nothing compared to old Lenovo machines, let's just say. So I have a simple Ubuntu session running on a piece of ThinkPad, which is my primary Linux development machine. But let's just say this is an Intel Nook that is on a local area network. Maybe it's doing something in an installation. Password. So this is a Linux machine that is running Ubuntu 24 LTS, and it has enough memory, as you can see, enough RAM, enough graphics. So how the development this is a target machine. To do the development on this target machine, it's going to be much more easier, and the method we are going to do and we're going to use is we're going to use Visual Studio Code directly to SSH into it and code directly into it from Visual Studio Code. So how do we do that? Let me exit here at this moment. Let me open up Visual Studio Code. For this, you don't have to install anything on the target machine yourself. So how do we do this? So you have Visual Studio Code. You need to have installed a plugin called the SSH dev, and it is, I think, let me see if it shows up Yeah, it's called remote SSH. This is the one that I'm using. You can just go connect to a host or just type in SSH and you'll have all the options. But primarily the first one to get started with, you can just go with like connect to a host, add a new SSH host. Just like you'd SSH login, you would do that. So my user is Linuxbox, and the rate, I know the IP, 921.168.1.188, I believe it was. If your host name is enabled, then you just type in the host name after the user. So that's what it is. Yes, click through. Oops. And it's going to show up here, connect. And it's going to open up a whole new window. And so now if you have your SSH key into the machine, it'll never going to ask you for the password. But since I don't have my SSH key in that machine, I need to put in the password. And once you're done with that, you essentially are in that machine, but now through Visual Studio Code. So the first time if you're ever doing it, I have done it before, it's going to download the Visual Studio Code server into that machine. So it takes like 5 seconds or 10 seconds. And it's going to take way more longer time if it's a low power computer like a Raspberry Pi. But if it's, again, as I said, this method is suitable for NUC and above in terms of hardware where we have like enough CPU and enough memory. So now essentially we get a terminal, which is Linux, which is that remote machine or the target machine. So in this, we are literally now logged into that machine from our Visual Studio Code, and we can access all the file system from here. So if we click here, open a folder, we can open a project folder. So this actually gives us the home directory. So for example, if I'm here, you can see we have everything that we can access. So let's open up something, right? Like let's open an old project of mine. Prototype Connect Embedded. Yeah, let's open that up, and it again launches up in this beautiful separate session. This is essentially, don't get daunted by this, but what we have here is the file system, or essentially the project folder from the directory. So now I can open up any of this code and I can edit it directly, and I'm now programming directly on the target machine, and it is fast, and there is no lag. And you can definitely have your Git and everything configured from here, of course. But the beauty is that now this is not your development machine, and you don't have to push it to the target machine. You are already in the target machine editing the code directly. So, and then again, as I said, you have the whole full terminal access here as well. So that's amazing. So that's method one. When you're faced with a challenge where your target application machine is not such a powerful machine, so it could be like a smaller Raspberry Pi or a smaller Nano Pi with like very limited RAM and like very limited CPU. How do you develop from Mac on that target machine? Our previous method is not going to apply here because it's going to be extremely slow. So in previous method, what we did is we essentially opened up Visual Studio Code like as such, code, and we tried to, once we downloaded the remote SSH plugin, we tried to log into the machine and work on that machine. So if we are doing here like this, for example, you'll see it'll take forever to even like, yeah, now I'm not being able to connect, but let's try again. And it's just taking forever. I mean, okay, it's not so forever, but like the file system is very slow. Like you see, like there's a lag, and you don't want that. So I don't know. Let's just open up a project here. Yeah. So you can see it's taking a while, right? It's setting up the stuff, and yeah, fine. And it's not even loading the properly, like all of that stuff. So everything is very slow, and we don't want that. So let's get out of here, kill this server, and what we do is we actually load the file system onto the Mac. Now the trick here is that, or the breakpoint here is that Mac has a different file system, right? It's Apple file system, AFS, or what is FAT32 and things like that, whereas in Linux it's primarily XFS file system, right? And so we need to actually load that file system on our Mac so our operating system can recognize it, and essentially on the local network. It's kind of like a shared drive. Essentially, you are loading that memory into the memory of the Mac, and then you then work from there. So how do you do that? Well, there is a plugin on Mac. It's called XFS. So let me show you that very quickly. You need to install that. So in our system settings on the Mac, you will see there is MacFuse, and MacFuse can be downloaded directly from the website or through Homebrew. So you can just run Homebrew, install MacFuse, and the first time you do that, because it's from an external developer, you have to activate that. I cannot show you right now on my Mac because I've already installed it, but you have to reboot the Mac in safe mode, essentially recovery mode, and from there enable plugins from external developers. And after that, you have to reboot again. It's like a one-time pain. Once that's done, your MacFuse is completely installed, and then you have to install something called install SSHFS. Once you are installed MacFuse and SSHFS, you can actually mount the file system from, let's just say, the low power Raspberry Pi. Let me just get out of here. And it has this mount point called Pi mount. So cd Pi mount. If we go in here, right now there is nothing because we haven't mounted the drive here. So how do we do that? We do SSHFS, and we essentially give it, just like we would do SSH, right? For example, when you do SSH file transfer as well, you would use some command like this. So you have the user, the IP or the host name, colon, and then you have the directory that you want to load. So my project directory on the Pi is stored in the home directory, and it's called Komorebi stick. That's the project directory, and I want to load it here on my local machine where I am currently at, in this mount point called Pi mount. And these are some other attributes that goes alongside to it. So let's load that. It's going to take a moment. Hopefully we are loaded now. So we'll see, enter the Pi mount directory again. And because we are now right now directly working over the network into this mount point, it sometimes takes some time. Yeah, so it has a git -l. And right now we are essentially, without quasi, let's just say SSHing, we are working in that loaded directory over the network here. So now I can start programming from here already. And the way I would do it is just like, yeah, open my Visual Studio Code from here. And as you can see, it is kind of loaded. And these file systems, as I make changes, are going to be directly working on the Raspberry Pi. So again, I don't have to like make changes on my local directory in the development machine, push it to a version control system, and then pull it back into the Raspberry Pi. Now I'm literally working on a mounted drive on the Raspberry Pi. This process is very different than the previous process. We have downloaded the Visual Studio Code server directly into the target machine. In this case, we are not downloading the Visual Studio Code because it's big and it'll just slow down the whole development process. Instead, we have loaded the file system or the target directory of our project into our development machine, and we have, before that, we have installed this file system management called MacFuse to enable X4 file system to be loaded on the Pi. And from there on, we are good to go. We are right now in the Pi, in this project directory that we are talking about, and we can do just umount, and we have unmounted the drive essentially from the Pi. So cd, if we do Pi mount, there is nothing anymore because we have unloaded the file system. Or if umount doesn't work, you can also do disk-util unmount target. So right now, since it's already unloaded, it's not going to work. So umount or disk-util you can use from the terminal if you have previously loaded using SSHFS. So again, SSHFS, your user of the target, IP or the hostname, colon, the directory you want to load from, and the target you want to load into, and these extra attributes. Take a screenshot probably, but also you can look at the man page of SSHFS for this. That's not a biggie. So that was the second method. So I have a machine over there that is a Raspberry Pi enabled robot. I built a test jig where I'm testing something, and I am running a Jupyter notebook. So if you're running Python programming, if you're doing Python development and you want to run a Jupyter notebook, let's just say in one of the single board computers, and want to have remote access through a web browser, that is also a paradigm of a real-time programming on the target machine, correct? So we can also do that. So let's say my remote machine is this one. I know the IP. I think it also has the hostname enabled. I still don't have the SSH key in there. Yeah, NSL, fetch, and yeah, as you can see, this is a Raspberry Pi 3B Plus. It also has significantly low memory, but we are not going to use Visual Studio Code at this point. So it is running a Jupyter Notebook server in there, Notebook Manager, and it's already spawned, and it's currently running, and it is actually, as you can see here, it is actually using that and notebooks. So I'm going to clear up from here, and instead I'm going to go to my browser, and we can access the Pi and the notebook directly from the browser. So if you I think this is the Jupyter notebook that we have installed, and it's a server. So what you can do is just go into the IP 192.168.1.237, I believe, /88888. That's the port I exposed the server to. Yes, so it is slowly coming to life. Yes, so as you can see, it's spawning up the server now slowly in here. It is slow, but it works. So and as you can see, I have a full-blown notebook loaded here, and I can manage all my notebooks from here. And this whole service is running through Jupyter, and this Jupyter Notebook Manager extension software for Raspberry Pi. And this is running straight out of browser. That's how notebooks work. I mean, you can run them IPython notebooks and Jupyter notebooks. But like this is very specific to a language called Python. So if you're interested in running Python in notebook environments, there is this amazing software for Raspberry Pis that can manage multiple notebooks and can expose the Pi over the local network, from where you can do real-time programming almost. It's not, but I just wanted to give you a demo that this way method is also possible. So we have learned 3 ways we can remotely work on our target Linux machines based on their CPU and available CPU and memory. We can work directly from our Mac as a development machine into those machines. I know that I went through them very fast, so if you have any questions about any of these specific methods, don't hesitate to reach out. Have a lovely weekend. Ciao.